Hello, my wonderful viewers. Today we are going to talk about this dive, grad, and curve. So, the meaning of this thing is what? Divergence, gradient, and what? Curve. So, we are going to first of all know what this symbol means. This symbol means what? Del operator or nabla. You can call it del operator or what? Nabla. This thing is what? A vector differential operator. It is what? A vector differential operator. Now, when nabla nabla operates on 5, we get what? What we are going to get is what? Grad. So if whenever nabla operates on what? 5, we are going to get what? Grad. And the result after getting the grad will be what? It will now be in what? A vector quantity. It will now be what? A vector quantity. It will now have what? Direction. When it operates on what? Grad. It will now have what? Direction. Now when nabla operates operates on a vector, let me write it on vector A. On Okay, on a vector A. The vector can be any name. Now what you are going to produce, okay, via dot product, we are going to have what? We are going to have what? Divergence, which is what? Dive. Now when nabla operates on a vector, the end product of this one will be what? It will be what? It will be in what? Scalar. It will be what? Scalar. It will not have what? Direction. When nabla operates on a vector A via cross product, we get curve, and the result will be what? A vector. It will have direction. It will be what? A vector. Now, seeing this, I'm going to clean this side. Okay, what is this thing telling us? That this thing is called what? Del or what? Nabla. Depends. Vector differential operator is also called what? The vector differential operator. Now, what is grad? That's gradient. You know, in plotting graph, gradient is the rate of change of what? Y over what? Rate of change of what? X. So gradient means change in Y over change in X. So this shows shows how this shows how quickly how quickly a quantity changes in the three variables in the three variables x, y, and z. X, y, and z in x, y, and z direction. X, y, and z. So it shows us how quickly a quantity changes in the three variable x, y, and z direction. So we are going to clean this place. that phi there is a what? It is a what? Scalar. So let's continue. Now the grad operating on what? Phi will give us what? Nabla operating on what? Phi. Remember, when Nabla operates on phi, we get what? Grad. So Nabla, Nabla is equals to what? I. Nabla is equals to I partial derivative all over partial derivative of x, then plus j partial derivative all over partial derivative of y, plus k partial derivative all over partial derivative of what? Z. So this is what? Nabla. This is Nabla. Now when Nabla is operating on this, we are going to have, remember, all these things are what? Vector. It has what? Direction. It has direction. So when it's operating on this, we are going to have I partial derivative of phi all over a x plus j partial derivative. Remember, it has what? Direction. Partial derivative all over of phi all over the y plus k. We have direction. Partial derivative of phi all over the z. So this is when Nabla operates on what? Phi. So this is what we are going to get. Remember, we say that after operating on it, we are going to get what? Vector. So it has what? Direction. Remember, vector quantities are those quantities that have numerical value and direction, but scalar don't have what? Direction. So now, this is what? For grad. Now, when we talk about what? Um, dive, when we talk about what? Dive. Dive, for example, you have Nabla, which is a vector, operating on what? Phi. Okay, sorry, Nabla operating on another vector, via dot what? Multiplication. Via dot multiplication. So this is dot multiplication. So we are going to have, this is Nabla. Nabla is what? I partial derivative of I partial derivative of I. Remember, is a vector all over partial derivative of what? X plus j partial derivative of what? J all over the y partial derivative of y plus k partial derivative all over partial derivative of what? Z. Now times our a is equals to what? A xi plus a xyz y j plus a z k. Remember, all of them are what? Vector, vector, vector. They are what? Vectors. Remember, this one is vector, 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 vector. So this multiplying this, we are going to have a is equals to this. So when this multiply this, we are going to have Nabla times a vector, we are going to have, remember, I times I is equals to what? 1. K times K is equals to 1. J times J is equals to 1. So we are going to apply it here. This times this, we are going to have partial derivative of ax all over partial derivative of x plus this one we multiply this one, it will be 1 times this is still the same thing of ay all over partial derivative of y plus this one partial derivative of az all over partial derivative of what? Z. So that is for what? Die. Let me snap it. So that is for die. Now let me clean. Let's move over to um this thing called. So call, when you have nabla or there operating on a vector via cross multiplication, this is the vector. So what is our nabla? Our nabla is I partial derivative all over the z, the x plus j partial derivative all over the y plus k partial derivative all over the z. So this is our what? Nabla. Now times a xi plus a y a j a y j y j a y j plus um a z k. So when this thing multiply, we are going to have what? So it will be in this form. You know, cross multiplication, we are going to arrange it in a matrix form. So it's going to be I j k. Now we are going to have the all over the x, the all over the y, partial derivative, the all over the z. Then we have ax, ay, and az. So this is what we are going to have. Now, remember in matrix, you close here, you bring out what? A first, I. You close here, close here. What we have is what? This times this. Partial derivative all over partial derivative of y times az, then minus partial derivative of all over partial derivative of z times ay. So this is what we are going to have. Now close. Now remember, using characteristics matrix, this one will be what? Minus j. If I close here, I get partial derivative all over the x times az, then minus partial derivative all over partial derivative of z times ax. I hope you can see it. Times ax. Now this place will be what? You bring plus k plus k. You close here and close here. See how we close it? Like this, and like this. That's how the method they are using to close matrix. You close here, you close T, you goes like this. So when we close them, we are going to have a all over the x times ay minus the all over the y times ax. So this is what we are going to get for finding this. So thank you for watching and may God bless you. Don't forget to subscribe on our YouTube channel. Follow us on our Facebook page. In our next video, we are going to solve questions concerning this. Bye bye.